I am Koit from the National Archives of Estonia, and I will tell you about SIARD, the database preservation format. In Estonia, we archive or preserve databases in two different ways. So historically, the first way was by exporting all the data into CSV files and exporting all the structural information into SQL files. And the new way is to export both the data and the structural information into SIARD files. When we talk about quantities, in the old way, we have archived about 4 databases, and in the new way, about 14. And I'm using the word about because, on the one hand, some of these databases included in the count are actually snapshots of the same database from different times. So if we would want to count the unique ones, then we would need to throw them out. On the other hand, there are some databases archived actually which are not for various reasons in this official count. So all in all, this is roughly our order of magnitude. This here is a depiction of the old way of doing things. This is a CSV file. CSV is error-prone. It does not contain the structural descriptions inside the data file. At best, you get the names of the fields, but you never get the format information, like that this field is plain text, this is a date, this is an integer, and you also never get relationship information, links to other tables. All this structure and formatting information is kept in those other files, these SQL files. And for this reason, it is really difficult to build automated access tools that would take all these archived pieces of data and present them properly. So for the lack of proper automated access tool, the way we provide access to this database looks like this. We really do have this running in the corner of a server where you can actually use this old MS-DOS-based Microsoft FoxPro. And we have trained a couple of archivists who know how to use it. So when we get a request from our customers, these archivists are able to use this ancient user interface and pull out the necessary data. Actually, this is not really a bad way of accessing this specific database because it's very simple. It's easy to host it in this ancient server. But it's not usable for modern information systems because they are just way too complex. You cannot really keep them alive over extended periods of time. So that's where SIARD shines. SIARD stands for Software Independent Archiving of Relational Databases. And the software independence part is best illustrated like this. In a live database engine, the data is stored as zeros and ones in some proprietary format, so that you cannot take the data files from one database engine and use them in another engine. Like Oracle data files are not usable in a Postgres database engine. And even worse, you cannot even use the Oracle data files in another version of Oracle database engine. This is obviously very bad for long-term preservation, so that's why we do SIARD. We transform these proprietary zeros and ones into a totally open text file in XML format, and specifically an XML format called SIARD, which is designed for database preservation. SIARD is perfectly standardized, perfectly structured, and perfectly machine readable. But in addition to that, when you pay attention to those XML tags, you notice that it's also mostly human readable. Like the tag DB name kind of hints at the database name, or the description kind of hinting that this might be the description of the database. And then you go down in this list of tags, you will get the descriptions of the tables and the relationships, and later you will get the actual data. It's all inside SIARD. And this characteristic of SIARD, that everything is in one file, very well structured and very standardized, allows for creation of these automated access tools. And there are several. This here is a screenshot from Database Preservation Toolkit, DBPTK, which is made by the Portuguese company Keep Solutions. Luis Faria from Keeps will later give us a speech, so you can ask for more details. But here and now, this is to illustrate the strength of SIARD, that you can really build this automated access. So whenever you load a database file into the viewing tool, the tool automatically detects all the tables that are inside this SIARD file. You can see them on the left-hand side column. But this specific tool also has this nice visualization feature. So every table is represented by a bubble. The size of the bubble indicates the number of rows in that table, and the color of the bubble indicates the number of relationships to other tables. So city table has got 4,000 rows and one relationship. And country table has got 200 rows and 2 relationships. For that reason, city bubble is much larger because it's got 20 times more rows, and the country table is darker because it's got twice as many relationships. When the user clicks on the city table, city bubble, they will be presented with a listing of rows from that table. And you can also see on top there is this search bar. The whole database is indexed for full text search. So the user can type their search terms without specifying which column they are targeting. The search is performed across all the columns of that table. So when I type Brussels there and run the search, then I will get all the rows that include the word Brussels in whatever column. In that case, there is just one of them. And when I click on this row, I will get the details of this record. And here we can see another strength of SIARD visualized. Because the structural information is included in the same file, the tool can automatically make these links to other tables clickable. So you see there is this bluish line there. When I click on that, I will be brought to the country table, to the corresponding record that has all the details visible. And this can go on and on. As you see in the top row, there are more of these clickable links. So in Estonia, we have worked with SIARD close to 10 years, and we have had various projects, some relatively easy, some very complicated, and I will now introduce you to 2 of our most complicated ones. So the first is the Register of Construction Works, which basically is about all kinds of buildings. The database in its original form in the Oracle database engine is about 800 gigabytes. This is not only plain data, but it also includes some embedded files that live inside the database tables. But in addition to these few embedded files, you also have 12 terabytes worth of external files that are stored in the file system, but database contains a link to this file. There are 200 tables in this system, which is about average, but there are over 1,000 relationships between 200 tables, which is completely unusual. This is our record. We have never seen that many relationships in any other database. In addition to basic data like dates and text fields and integers, there is also a lot of geodata in this database. And when we archived it, in addition to everything that is listed there, we also archived some views. Views are sort of artificial tables where data is pulled together from different tables to cater to common usage needs, so that the data that is frequently used is in an easily accessible table. So after doing these views and archiving everything else there, the archival package was roughly 20 terabytes. The other interesting case that gave us a lot of headaches was environmental service registry, which is much smaller. The database is only 59 gigabytes. But when we received it and started to load it into our servers, into our database preservation toolkit to validate it, it failed because we ran out of something called inodes. In a file system, every file has got a name, but it has also got a number, numeric identifier, which is not normally exposed to the user. But there is always a limit on how many of these inodes can be given out. And in our server, the limit was much lower than was needed to accommodate all these millions of files that came with this service registry. And the reason for having that many files was there was a lot of geodata in this database. And the SIARD creation tool exported these large geodata blobs. Blob means large object, basically long text fields with a lot of these coordinate pairs, latitude, longitude, that form points that when connected to a contour form some sort of a shape on a map. So these were exported into external files. And the solution was we ordered a new feature so that you can actually configure the threshold, how large objects are exported. So you can say, let's say, any this geodata text object that is less than 1 kilobyte in size stays inside the database, and only the very larger ones get exported. And actually, there is now the opposite feature as well. So you can say that if the database originally had some external files that were very small, you can tell, please, any external files less than 1 kilobyte, bring them into the main SIARD file during archiving for the same purpose of limiting the number of these external files that can overwhelm the file systems. So in both of these crazy cases and also in all the milder cases, SIARD has served us really well. But there is one idea for improvement that we haven't figured out how to handle thus far. Remember I mentioned that there was 12 terabytes of external files with this buildings registry. And also I said that in addition to the main tables snapshot, we archived some views as a separate snapshot. And it turned out that some of the records in the views referenced the same set of external files. So we ended up with duplicating some of these files. And with quantities in the neighborhood of tens of terabytes, it's a lot of wasted space. So it would be nice to have this capability of having one set of external files and then reference them from as many SIARD files as necessary. To conclude, our ingests of databases usually take ridiculous amounts of time, and there are various hindrances that make this process slow. So oftentimes the problems are with the agencies that transfer those records to us. Archiving is never their first priority. It's not even the third priority. It's their 13th priority. Second, they tend to have complicated procedures, like rules of conduct, which artificially slow things down. And third, we at the National Archives, we are also not perfect. Sometimes we get busy with other tasks and then an ingest can get stuck behind us. So organizational matters. Then sometimes we have issues with the tools, as I gave this example of millions of files, which we then fix with ordering a bug fix or a new feature. But we have never had problems with SIARD. Thank you.